If you are watching this video for the first time, make sure you are subscribing to Untitled Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everyone, welcome back to Untitled Academy. As told in the last video, today we are going to cover the concept of finite and infinite sets and cardinal number of sets. Even before this video, we have already covered the introduction of sets along with exercise 2.1, which includes the roster form and set builder form. And apart from that, we also have covered the universal set, subset, Venn diagrams, operations on sets like union, intersection, and difference of sets, along with exercise 2.2 in a separate video, which is released as sets part 2. Along with that, we have also covered the concept of equal sets and exercise 2.3 and released as sets part 3. Today we are in sets part 4 video, wherein we are going to discuss the finite and infinite sets. Finite and infinite sets. Alright, so before we go to get into this concept, so let us understand the term finite. What is finite and what is infinite? If you look at these two words, we can figure out that finite and infinite are opposite words, isn't it? Finite, opposite of finite is infinite. Alright, so they are opposites. Well and good. Now that we have come to a conclusion by looking at the statements, the words itself. Now, what is a finite? When you keep on writing a set, like, so let me say it as, let me explain you with example so that you would understand it really better. So I have a set of A, B, C, D, and I have a set B. It says X such that X is a natural number. Alright. Now that elements are listed in A, I do not have a problem. For me, I need to list out the elements for B because I cannot solve any problem like this. Alright, so let's figure out that. What is natural number? Natural numbers begins with 1, 2, 3, 4 and so on. If you are not familiar with number systems, please go through the real numbers part 1 video wherein I have explained the number system very clearly. Alright, so this goes on 5, 6, 7, 8. Since there is no limit mentioned in the set builder form, I have put and so on. Alright, so here if you look at set A, how many elements are there in set A? 4. What are the elements? A, B, C, D. Alright, now if you look at set B, if I am going to ask you guys how many elements are there in set B, can you answer that? No. Why? Because I haven't put an end element to this. And so on is something which is nothing but which indicates that there is no end to this. Alright, so 1, 2, 3, 4, 5, 6, since I have written just 7 elements, and can you say this as a set which has 7 elements? No, you cannot say that because we have and so on here, which says that this set is not finite. This is not finite, which is nothing but we cannot count the elements in this set A. So this is a finite set wherein I can count the number of elements. I know how many elements are there in set A. This is a infinite set wherein I do not know how many elements are present and I cannot count them. Once you know the elements, you can count them. When you do not know till where it goes, it may go to till 1 lakh, it may go till 1 million. You do not know, right? So this is an infinite set. Any set which is not finite is also an infinite set. The simple definitions, right? Finite sets are nothing but the sets which are having static number of elements, I mean countable number of elements. Alright, but infinite sets are nothing but sets which are not finite. That is a very simple definition of it. Or else any set in which you do not know till which element you have this set for, or the best definition would be a set which is not finite is an infinite set. So how do we address this? Like, in order to put it in a statement, finite sets are nothing but a set which are having the elements which are countable, and the set which does not have an elements which are countable is known as infinite set. That is about the concept of finite and infinite set. Next concept we are going to discuss is cardinal number. Cardinal number of set. Let us assume a set has A, B, C, D, and B is a set such that X is the letter in the word India. I love my India. All right. It's not I love my India, it's just India. All right. So, and let us assume C is a set of X such that X belongs to N and X less than 5. All right. So now that A is already elements listed, can I list down the elements for B? Yes. What are they? I, N, D, A. Why is the second I not present in the sense? Because it is a duplicate set, does not allow duplicates. Alright. And the third set is X belongs to N and X is less than 5. 1, 2, 3 and 4. Okay. Alright. So, coming to the concept of cardinal number of set. Cardinal number of set is nothing but the number of elements that are present in the set. Alright, so if you consider the set A, how many elements does it have? 4. 1, 2, 3, 4. Isn't it? So cardinal number of a set is denoted as n of set A is equal to how many number of elements? 4. Cardinal number is given by the symbol n of, n in and braces. Within the braces, within the curve, and these are not curved braces, normal braces. Within that you will write the set. So what is the cardinal number of B now? How many elements? 1, 2, 3, 4. Yes. What is the cardinal number of C now? 1, 2, 3, 4. Again, it is also 4. So that's about the concept of cardinal number of set. I hope you guys understood the concept of finite set, infinite set and the cardinal number of a set. So once you get to know the concept, I request you guys to go through the examples before the exercise problems. Now I'll be starting on the exercise problems. If you have not gone through the examples, just pause this video right here and go through the examples. They are quite simple and it will not take you more than 10 minutes. Alright, just pause this video here and go through the examples. By then, I'll be ready with the exercise problems already listed on the board. Yeah. Here I am ready with the problems already listed on the board for exercise 2.4. There are only 2 problems and a couple of bits we need to solve them. So the first problem says that state which of the following are empty or non-empty. Alright. What is an empty? What is empty? Empty means there is nothing present in it. Means there is nothing in the sets, just the braces itself. Alright. So let's try figuring out which of them is empty and which of them is not. The set of lines passing through a given point. Given a point, how many lines can you draw passing through the point? Dun, 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 dun. Like this, how many ever lines you want, you can pass. Can you count on these lines? How many lines? No, right? So this is a non-empty set. There can be n number of lines which is passing through a given point. So this is a non-empty set. Next, set of odd natural numbers divisible by 2. When you say set of odd natural numbers, they are 1, 3, 5, 7 and so on. Now, if you go through them, are they divisible by 2? No. So, by 2 is, you get nothing, which is nothing but this is an empty set. Okay. Next, x such that x is a natural number wherein x is less than 5. What are the values less than 5? 1, 2, 3, 4. And greater than 7. Is one either of the 4 elements 1, 2, 3, 4, is it greater than 7? No. So the set is empty, which indicates this is empty. Next, the fourth bit, x such that x is a common point to any two parallel lines. Parallel lines can be of two types, like either they are horizontal parallel lines or they are vertical parallel lines. They go on like this. There is no meeting point for those parallel lines. So this is empty set, which indicates empty. Set of even prime numbers. What are the prime numbers? Prime numbers are nothing but which get divided by themselves, and other than them there is only one. One is the number which divides them. They are prime numbers. So we have 2, 3, 5, 7. They want even prime number which is just 2, which indicates this set is non-empty set. Alright. When you look at this empty set, is there an element in it? No. Right? Yeah. State finite or infinite. Now that we are going through finite and infinite problems, let me ask you guys a question. So, when we are discussing about the cardinal number of set concept, we thought there should be, when there are elements in it, and when there are elements in the set, we just counted them. Now, the question arises. So, can we calculate the cardinality of an infinite set? What is an infinite set? Which has unknown number of elements. Number of elements, there is no limit for those number of elements. Hence, we could not count them. That is what we said infinite set. So, can we calculate the cardinality for infinite sets? The answer is no. The sets are called infinite because we were not able to list down all the elements in it. When you can't list down all the elements in it, you cannot count the elements in it. And hence, the cardinality exists only for the finite sets. Please make this a point. Note this as a point. Okay. Now that we are going to state whether this is a finite or infinite statement. So, the first bit is the set of months in a year. What are the set of months in a year? The set starts with Jan, Feb, March, April, and it goes on till December. Is this finite? Yes. There are 12 months in a year. So, this is finite set. The second bit, 1, 2, 3 and so on, it goes on. You have the limit for this till 100. So, there are 100 numbers. Now, this is also finite set. Okay, if there is no limit, the 100 is not there, then that is going to be an infinite set. Now, set of prime numbers smaller than 99. If they just said set of prime numbers, that is an infinite set. But they have given the limit smaller than 99. Hence, this is also a finite set. And the fourth bit is set of letters in English alphabet. How many letters do we have from A to Z? 26. Now, these are countable. Hence, this is a finite set. Set of lines parallel to x-axis. X-axis is nothing but a horizontal line. How many lines you can draw parallel to x-axis? N number of lines. You can draw how many ever where n belongs to n. So, this is also infinite. Why is it infinite? You can draw so many lines parallel to x-axis. There is no limit for that. You cannot count on them. Set of numbers which are multiples of 5. 5, 10, 15, 20, 25, 30 and it goes on. There is no limit mentioned for this. So, this set is, if you try writing a set 5, 10, 15 and so on, it goes on. You do not know the upper limit of this. So, this is also infinite. And the last statement is set of circles passing through origin 0, 0. So, origin is nothing but like this. If you consider this as x-axis and this is y-axis, this is the origin. You can have a circle like this, like this, like this, like this, like this, like this, and how many ever circles you want. You can draw so many circles, so big circles, and it goes on. There is no limit for that. When you have no limit, then this is also infinite. All right, so this is about exercise 2.4. Congratulations, we have successfully completed the second chapter of 10th class mathematics, which is sets. So Anantalakshmi Academy has completed 4 chapters till now of 10th class mathematics. If you are watching only this video, please make sure to go through the rest of the chapters as well. They are quite easy. And if you feel that the content is worth enough, please do like, share and subscribe to Anantalakshmi Academy channel. Also publish this or post this or share this to your 10th class friends or any of the relatives who are studying 10th class. So that's about sets chapter. Post this, I'll be starting on the third chapter, which is polynomials. So wait and watch till we make a video on polynomials chapter. Thank you for watching.